Dear viewers, greeting to all. I'm Arunachalam, Assistant Professor, Department of Chemistry, Mr.T.Arunachalam College. Today, we are going to discuss with the main title of the quantum chemistry, in which specifically we are going to discuss with the Hermitian operator. So, the importance, why the operator is important in chemistry. So, when you consider the classical mechanics for any moving object, the observable, for example, position, momentum, energy are calculated directly, but in quantum mechanics, each observable in the classical mechanics has corresponding quantum mechanical operator and the wave function, from which only we may easily calculate the energy, position and momentum of microscopic moving objects. So now, before that, we should know what is operator. The operator means, for example, we all know very well, you take this is an operator, but the addition operator. This is subtraction operator, whereas this is the multiplication, and we may take this as division. All these are operator, from which we may easily define the operator is one which operate an operand and produce some result. For example, if you take the number 5 and number 6, if we use the operator, addition operator, we will get the result 11. The same thing, if we use the operator subtraction, 5 minus 6, the result is being minus 1. So it depends upon the operator, the same operand will produce the different result. Okay. Then another importance of the operator. Some of the operators are considered as linear operator. Linear operator. For example, you take the operator d by dx. This is an operator. So this is an example of linear operator. Why? Because if you take the function f of x, comma, and g of x, if you are using the operator d by dx, if you operate this function collectively, that is d by dx of f of x plus g of x. This can be written as d by dx of f of x plus d by dx of g of x. When the operator, if the left hand side and right hand sides are equal, then the d by dx operator, call it as linear operator. Thus, hence it is a linear operator. Whereas, if you take an example of root, this is another operator. If you take root f of x plus g of x, which is not equal to root f of x plus root g of x. So from which we may easily identify the root is an operator, it is not a linear operator, because the left hand side and right hand sides will not be equal. So the another importance of the operator. So now next we'll move to what is Hermitian operator? Hermitian operator. The Hermitian operator means if you consider an operator A, if A is an operator, A is an operator, pi and psi are two wave function. Phi and psi are two wave functions. Then the operator operate this function such that pi A into psi star be equal to this is the condition for the Hermitian. So when you integrate the two wave function by using the operator A such that, or we may write in another way also, psi star A into pi t tau should be equal to integration of pi A into psi whole star into t tau. If this is the exact condition when the both left hand side and right hand sides are equal, then the operator A call it as the Hermitian operator. Operator A call it as Hermitian operator. So the another important thing we have to remember, so when you integrate this using the operator, we have to use the limit minus infinite to plus infinite, minus infinite to plus infinite. So when you integrate between minus infinite to plus infinite, or we may exactly call it as integration between the symmetric interval. Symmetric interval means nothing but if you integrate this with respect to minus 5 to plus 5, minus 10 to plus 10, or 0 to 2 pi, these integration limits are called it as a symmetric interval. So when the condition is satisfied, the operator A is called it as Hermitian operator. Operator A is called it as Hermitian operator. So now the another thing, next we are going to the proof of the Hermitian operator. Proof of the Hermitian operator. When you prove that, you take the two function where pi is equal to e power ix, and take two function psi is equal to sin x. If when you consider these are the two functions, and the operator d square divided by dx square, then if the operator d squared by dx squared is a Hermitian, this should satisfy the function like this, integration of minus infinite to plus infinite, where you take the psi star is sin x alone. Psi star is nothing but the complex conjugate of psi, where psi, if any complex number is present here, then i's became minus I, or plus became minus, or minus became plus. Here there is no complex number, so are not necessary. Psi is equal to psi star. Psi is equal to psi star. We may take as psi is equal to psi star. Then d square divided by dx square e power ix into dx. This should be equal to integration of e power ix d square divided by dx square sin x whole star into dx. If these both should be equal, so then only the operator d square divided by dx square became Hermitian operator. Hermitian operator. When you integrate this, it's very simple. Not necessary to substitute the limit everything. If you find the second order differential of e power ix, is became, that is sin x d by dx of I into e power ix. We take LHS only. Dx. And further, if you differentiate once again, minus infinite to plus infinite, sin x, again i's became here, that is I square e power ix dx. So I squared is nothing but minus 1, that is integration of minus plus infinite sin x e power ix dx. This is the left hand side. So when you take the right hand side of the equation, the power hs integration minus infinite to plus infinite e power ix. When you differentiate 2 times sin x, first time, that is d by dx, differentiation of sin x is became cos x. Once again you differentiate cos x, minus infinite to plus infinite e power ix. When you differentiate cos x, this became minus sin x. Now we rearrange that, you take the minus sign outside of the integration, minus e power ix sin x dx. So now see, left hand side you get the answer this, right hand side also the same result. Hence the operator d square divided by dx square is a Hermitian using these two functions. Okay, dear viewers, I hope you understand the concept of Hermitian operator. Thank you very much. We will meet by the next videos. Thank you very much.